Hydac has had great success collaborating with customers on filter tank optimization. Specifically, we analyze and optimize the deaeration function of the tank and filter. Before we get into the details on how we do that, let's talk about how tanks are typically sized. When sizing a tank for a hydraulic system, you need to consider the sizes of the cylinders in the system. As cylinders extend, the tank level drops, so you need enough volume to account for that. You also need to allow volume for thermal expansion as the oil heats up. You typically allow for some safety factor so that if the tank is slightly over or underfilled, the system still performs well. Beyond that, the main factor driving tank size is, in fact, air. Any hydraulic engineer will tell you that air in the system is bad. And traditionally, the only way to deaerate a system is to make sure that the tank is big enough to allow the oil to dwell in the tank, so that any air can rise to the surface. If you have an aeration problem, you need to make your tank bigger. And if you try to shrink your tank too far, you run the risk of aeration problems. Most tanks on the market have been designed using best practices or rules of thumb. You need to keep the turnover rate low to allow dwell time. You probably want some baffles to prevent sloshing. And you need to take care to place your return and suction ports wisely. They shouldn't be near or pointed at each other. You might add a return diffuser to slow down the oil velocity. Most OEMs don't have the resources to do detailed analysis on their tank design, so they rely on these proven best practices to avoid issues. As a result, you don't tend to see a lot of machines with aeration issues in their hydraulics. They've been designed to avoid aeration. However, what you do see are tanks that are larger than they truly need to be. This drives higher cost, weight, and space claim. To help address these issues, Hydac takes a different approach. First, we do detailed analysis of the tank to assess its deaeration performance. We understand the physics that govern the behavior of air in the system, and we simulate that behavior to evaluate the system. In addition, we have proprietary filtration technologies that use an in-tank return filter to separate air from the oil. This allows us to design the tank and filter for optimal deaeration performance, and we no longer need to carry extra oil just to allow dwell time. Hydac has performed hundreds of filter tank optimization projects, and we've always been able to reduce the tank volume. We typically achieve at least 20% reduction in tank volume, but it's common to see a 50% reduction or more. This results in a lower system cost, reduced space claim, and reduced weight for both the oil and the tank. Check out the full breadth of Hydac products at hydac.com.